just to highlight a few things that we'll be talking about today. We'll go through the PMA approval pathway. How do you get there? We'll spend a fair amount of time on product testing relative to the DO-160 commercial standard. Kevin will bring the technical discussion around those sections. We'll talk about when testing is required in the PMA pathway. And then we'd like to spend a fair amount of time, certainly, on the NTS testing solutions. We're a very robust and widespread organization that can help you with the testing that you require for your products. So PMA, probably don't have to spend a lot of time relative to PMA and what it is, but PMA parts have really been a vital part of the aerospace supply chain for many years. It started back in the mid-50s. The FAA certified that their rule was to be equal or better than the OEM component that was replacing. There have been myths around PMA parts for years. They have been just that, myths, in the fact that they weren't robust enough. You might affect the life of the product, therefore the life of the aircraft or subsystem. And those are just blatantly false. They've been proven false over the course of time. They are very, very reliable components. They're cost effective. They are under the same quality guidelines as the OEM. And typically we find better inventory, which means a faster replacement for the folks that are ordering. So PMA is a vital and continues to be a vital part of the aerospace supply chain. Some of the governing regulations are found in USA 49 Title 14. You can read there. The governing rules for PMAs for design application is 14 in the CFR 21.303. They have to be, as I mentioned, produced under approved quality system that are audited and achieved in a robust manner. They do have the same production requirements as the type certificate or the holder for engines and aircraft parts. So again, we find the reliability of the PMA parts are equal to, if not better. They carry a combined design and production approval. Aircraft certification offices or the ACO find the design compliance. Manufacturing inspection district offices approve the production methods and keep the quality system robust and in effect. PMAs do include the installation eligibility on specific models and products of type cert aircraft. And again, PMA will continue to play a vital part in the aerospace market and the rebound of that market. I'm going to go to the next slide, Sam. 4 basic approval types or pathways to a PMA. Identicality, I'll call it similarity for the lack of a better term, with a license agreement holder. The design's licensed to the PMA approver by the STC, the supplemental type cert owner. In the OEM market at the moment, the FAA has been a little less, they've been more reluctant, I'll call it, to qualify OEM parts and systems via similarity reports, especially after the 737 MAX issues. So we see some of that coming down through the PMA models as well. The second way to achieve the PMA approval is the supplemental type cert. That's FAA approved. It's a method for the holders to produce their STS parts instead of obtaining a production certificate. It's 9 months to a year to achieve that. The costs are front loaded. You do bear the cost of engineering, of development, of testing, to not speak of the cost of overhead and marketing, etc. You have a path for similarity without a license agreement. The applicant will show their part design is exactly the STC holder's design. Typically need to have the STC design to show every aspect is the same, so similarity with approvals. You see the orders there on the slide that provide the policy and the guidance in the FAA and the FARs to complete that. You're only allowed very minor changes to material or design. So that's the third path. The fourth path that NTS really plays into and support the aerospace organizations is test reports. Um, Typically, we see reverse engineering designs. You have to comply with all of the airworthiness requirements. You see the two orders there that provide the same policy and guidance. You can make some minor changes with proper sustainability adjustments. And again, this is where NTS is going to serve the marketplace through DO 160 testing, through MIL standard type testing, across a broad section of EMI, EMC type testing, as well as environmental to show durability and sustainability over the life of a particular part or a program. And we'll get into more of that as we go through the presentation. Next slide, please, Sam. So why would the FAA support PMA parts and license holders? There really has been, again, a confidence built up throughout the marketplace since the 50s. When we came out of World War, there was a large stock of inventory that they really had to place in the aerospace market. So we've had a very long and dynamic history of successful approvals that keep the FAA parts, PMA approved parts in the marketplace. PMA parts can fill a need when the industry is going through replacement articles. As you can see there, many PMAs are no longer produced or supported by the OEMs. And that sometimes can be as long as 15 to 25 years for the tail of an aircraft or a production program. 75% of PMAs are through license agreement or STCs. We talk about a mature and robust process. That really is the key to supporting PMA and FAA approval. They've been vetted throughout history of the parts. The original order was released back in 1995, and the operational safety and supports, or the operational safety that we see supports a position of PMA parts being into a type cert aircraft with absolutely no degradation in life or virtue of the part. And that's seen through testing and through sustainability in the marketplace. Next slide, Sam. A couple of graphs to support the PMA parts and their metrics. As you can see, these two present the number of PMA parts in the marketplace over time in the two sections, similarity and then testing. Back in the 2010, 2015, we saw a spike of parts introducing the marketplace. As you can see, it's come down since then, with testing still being the I'll call it the lagging way to get a PMA approval through FAA, because once again, it's a longer process, probably a little bit pricier than similarity reports or just computation by engineering analysis. But we still see that is going to degrade over time until the pandemic is relieved and the flying public is back to some degree, that the airframers, along with the airlines, continue to buy aftermarket parts. Next slide, Sam. This is just a graph to show the number of PMA parts that were introduced in 2019 and how they got there against the 3 or 4 ways to get a part into FAA approval. And you can see the green section there is the testing, again, the one that NTS plays into the approval process. And over time, whether it was last year, 2019, when the passenger revenue miles were up in a sustainable level, actually some of the highest levels we've seen, or if it's parts over history, the percentage of the way for PMA parts to introduce into the supply chain is relatively the same, testing at 18 to 20, 25% of the marketplace. So it's again a big sector. It's a sector that NTS has sustainable growth in and seen historical growth in, and we stand ready to still continue to serve that marketplace as we go forward. Next slide, Sam. This goes against cuts across the same data relative to the number of PMAs issued, but what it does is it just gives you the visual array of the four types of aircraft that it serves. The largest part is Part 23, which is the civil aircraft, or excuse me, the civil aircraft is Part 23. The largest is Part 25. That's the commercial transport. That's the airlines out there that are flying through the marketplace in the world. Parts 27 is rotorcraft, a much smaller segment of the market, and then the last one is the engine manufacturer. So you see, it's dominated by the commercial aerospace OEMs as you would expect. This next slide I wanted to present just as it says, the commonly tested systems and subsystems. They cut across all chapters of an OEM aircraft, from the engine to power distribution to generation to emergency APUs, pumps, etc. Components that comprise mechanical as well as electrical hardware, um, nose to tail, as it were. So these are the types of systems and subsystems that NTS test across our array of 28 test facilities. And we bring to the party here EMI testing for reliability, susceptibility, and radiation. We bring environmental aspect testing to a lot of these commercially produced systems and subsystems.
Once again, on behalf of the association, thank you, gentlemen, and everyone. Have a great day.